Okay, let's be real for a second. Machine learning is, well, it's everywhere. It's the magic behind your social media feed. It's helping doctors spot diseases earlier. And yeah, it's even making your smart home, smarter. It's this incredible tech that learns from data to figure things out on its own. But, and this is a big but, all that power comes with some pretty serious hidden risks. And that's exactly what we need to get into today. So, to really get why this can be so tricky, you've got to understand this fundamental shift in how we build things. Think about old school programming, right? A developer sits down and writes a bunch of if this, then that rules. You give the computer the rules plus some data, and bam, it spits out an answer. Simple enough. But with machine learning, whoa, you flip the whole thing on its head. You give the machine a ton of data and the answers, like thousands of pictures of cats that are all labeled cat, and you tell it, you figure out the rules for what makes a cat a cat. And it's that part where the machine makes up its own rules that's both mind-blowingly powerful and, you guessed it, super risky. All right, so let's just quickly define what we're talking about here. At its heart, machine learning is a type of AI that learns from data. It finds patterns and makes decisions, all with very little help from us humans. And the promise here? It's absolutely huge. We're talking about getting automated insights from these gigantic, messy datasets that no person could ever hope to sort through alone. Now, every single machine learning model runs on one thing: data. And not just a little bit of data. We're talking mountains of it. It's the fuel for the engine. But here's the catch, and it's a big one. That very foundation, the fuel itself, is also where its biggest, most dangerous problems come from. And this scale we're dealing with is just, wow, it's staggering. I mean, check this out. There's an AI app for cosmetics that can analyze the ingredients of over 45,000 different products. 45,000. And it does that to give you personalized recommendations. I mean, that's the kind of massive scale where machine learning just leaves everything else in the dust. But that power is a total double-edged sword. Every amazing thing it does, all the pattern spotting, the predictions, it all comes down to the data it learned from. So the big, scary question is, what happens when that data is flawed? What if it's biased or incomplete or just wrong? Yeah, because bad data isn't just some tiny technical glitch. We're talking about real, serious human consequences. You see, if you train a model on data that's full of our own historical biases, say from decades of unfair hiring practices, guess what? The AI learns to be biased too. It just automates that discrimination. And that leads to all sorts of problems, from systems that were great for one group of people but fail miserably for another, to massive privacy breaches where sensitive info gets leaked. And if the data problem wasn't enough, we've got something else to worry about. What people in the field call the black box problem. With the really complex AI models, the way they make decisions is so tangled and, well, weird that even the people who design them can't fully explain why it made a certain choice. You can see what goes in and what comes out, but the how and why in the middle, total mystery. And that right there is what's so terrifying about the black box. As this quote says, these systems can fail silently. A model could be making biased, messed up, or just flat-out wrong decisions, but on the surface, everything looks fine. There are no flashing red lights, no error messages. It just keeps chugging along, silently causing harm that could go unnoticed for, well, for years. Okay, so this isn't just some academic thought experiment. It's time to move from theory to reality. Because these problems with data and black boxes, they've already caused serious real-world harm. Let's look at some examples. Take a look at this case with Rite Aid. It's a perfect storm of what can go wrong. So they roll out this AI surveillance system in their stores. Fast forward a couple of years, and reports start pouring in that the system is constantly making mistakes, wrongly accusing people of shoplifting. And here's the kicker. It wasn't random. The errors were way more common for Black, Asian, and Latino customers. It got so bad that the FTC, the Federal Trade Commission, had to step in and ban them from using the tech for 5 whole years. Their words, reckless use. And Rite Aid is definitely not an isolated case. The risks are all over the map. You've got stuff like emergent behavior. Remember Microsoft's Tay chatbot? They let it loose online, and it pretty much immediately learned to be incredibly offensive. Then there's the environmental hit. Training these huge AI models takes a mind-boggling amount of energy. And maybe the biggest one of all is growing inequality. When biased systems are in charge of who gets a job or a loan, they can end up just making society's existing inequalities even worse. Okay, so that's a lot of heavy stuff, I know, but it's not all doom and gloom. The good news is a lot of really smart people are working hard on solutions. So let's shift gears and talk about the path forward, how we can build AI that's not just smart, but also safe, fair, and something we can actually trust. First things first, we have to tackle what you could call the original sin of machine learning, the data. To build a good model, you need tons of high quality, diverse, unbiased data. But what if you can't get it? What if it's super rare or expensive? Or worse, what if it's already full of the exact biases we're trying to get rid of? Well, one of the coolest solutions out there is something called synthetic data. Basically, it's high-quality, artificially generated data. Think of it as computer-generated fake data that looks and acts just like the real thing. This is a game changer because it lets developers fill in the gaps where real data is missing. They can create scenarios for rare but super important situations, and they can deliberately create a perfectly balanced dataset to fight back against those historical biases. And the best part? No one's private info is ever at risk. And that brings us right to the next big problem, privacy. I mean, think about it. How can you possibly train an AI on super sensitive stuff, like all of our private medical records, without gathering it all in one place and creating a giant, tempting target for hackers? This is where a really clever idea called federated learning comes in. Here's how it works. Instead of bringing all the data to one central model, you send the model out to the data. It's kind of like sending a student to a bunch of different libraries. The student learns from the books in each library, but only brings back the knowledge, not the actual books themselves. So the AI model learns right there on your local device, like your phone, or on a hospital's private server, and only the lessons it learned, the model updates, get sent back. Your personal data never, ever leaves your device. And that brings us back to our old friend, the black box. Because let's say we solve the data problem completely. We still have to ask, how can we ever really trust an AI's decision in a life or death situation, like a cancer diagnosis or a sentencing recommendation, if we have absolutely no idea why it made that choice? Well, that is the entire mission of a field called explainable AI, or XAI for short. The whole point of XAI is to build models that can actually explain themselves, that can justify their decisions in a way that we humans can understand. It's all about cracking open that black box so that a doctor or a judge or you can look at an AI's recommendation and say, okay, I see how you got there. It's about turning AI from a mysterious tool into a trustworthy partner. But at the end of the day, all these brilliant technical fixes are only one piece of the puzzle. As AI gets tangled up in every part of our lives, it leaves us with this one huge, critical question. Who's responsible for how this powerful tool is used? Is it the engineers who write the code? The companies who sell the products? The governments who are supposed to regulate them? The honest answer is, it's probably all of them. And that is a conversation that we all need to be a part of, starting right now.